All right, Chapter 7, Lesson 3 talks about similarity and transformation. So in the previous lessons, you've heard me say something like similar and congruent. Similar and congruent. So really what this means is something is similar. The book's definition says if the second can be obtained by the first by sequent of transformations and dilations. Here's a shortened version that I would say. It's the same shape, but not necessarily the same size. Can be, but not necessarily the same size. They could either shrink it or dilate it, shrink it or enlarge it, however you want to put it. So similarity is the same shape. This right here is the same exact shape, only one is bigger or smaller than the other. So similarity is the same shape, not necessarily the same size. So to prove similarity, they talk to you about using dilations, some form of transformations. So dilation would mean to make this blue triangle larger. All right, so we can talk about the lengths of their sides to prove if they're similar or not. So they talk about writing ratios. Here's how I would do it. So I would compare small to big and compare corresponding sides, which we just learned about in lesson 2. So if I'm doing small on top in the first one, this is 1, 2, 3, 4 units long. ED is 4 units long. What does that correspond to? That would be HG, which is 1, 2, 3, 4, 5, 6, 7, 8. Okay? So this is to this as, now I would not take the slanted sides of any triangles. Why? Because in order to properly get that length to an exact measurement, you cannot just count anything. You're going to have to use Pythagorean theorem. I don't really think you want to do that. So I'm going to say take the other one. 1, 2, 3. So 4 is to 8 as 3 is to what? 1, 2, 3, 4, 5, 6. Now, if these are the same, then they are similar. So I would even check, you could do this. Do these multiply out to the same? 4 times 6 is 24. 8 times 3, 24. The book here talks to you about reducing them. They actually put the other one first, which is fine. They compared big to small, does not matter. So they got 2 to 1. If I were to take this and reduce it, I would get 1 to 2. And again, that's because they compared big triangle to small triangle. They compared big to small. I compared small to big. Does not matter. So I got 1/2. They got 2 over 1, which is fine because those are just reciprocals of each other. So you can check the rates by multiplying, because if it is a true proportion, the diagonals, the cross products, would be equivalent. So if the cross products are the same, then it is a proportion, which means that they are the same, they are similar, or you can just make sure that they reduce to the same thing. Either way you want to do it is fine with me. Some are more appropriate in certain situations than others. Okay, example 2. Determine if the two rectangles are similar by using transformations. Now, here's what they have you doing. They have you taking this blue rectangle and rotating it around, just taking it and basically standing it up. You can do that if you're not good at looking at something and saying, okay, this corresponds to this, this corresponds to this. That is a perfectly legitimate way of doing it. I feel, for myself anyway, that that's really kind of unnecessary. So I would just be able to realize that by looking at this, T would correspond to what? Y. And let's say W would correspond to what when we stood it up? X. All right, so it just depends. If you can see things that way, that is fine. If not, you can transform it up here. I just think that this is a place that can make errors rather quickly. That's just one more step to do, which just means it's one more place you can make a mistake. So if it were me, I would probably not do this. But again, you do what works for you. So again, if I'm going to compare these, I would compare sides. I could compare TU. So if I'm going to compare small to big, again, this is just the way I do it, small to big. 1, 2, 3 units. The big side that corresponds to that would be right here, which is 1, 2, 3, 4. Okay, now I have to pick another side. So if I pick another side, let's pick this one. Again, if I do small to big, then my small side has to go on top. That's 1, 2, 3, 4, 5 units long. That corresponds to what? This one right here, which is 1, 2, 3, 4, 5, 6, 7. Now, 3/4 and 5/7 are not going to reduce to the same thing. You can check cross products. That would be 21. That is 20. So those are not the same. Therefore, these two rectangles are not similar. So you cannot just go by your eyes and say, oh yeah, they look about the same, only one's a little bit bigger. They do not have the same proportions. They do not have the same scale. So these are not similar. All right? Those are not similar. Okay, next page. Let's have you try some. So I want you to pause it and try A and B for me, please. Okay, back with me. Let's try this. First one. What am I going to compare here? Let's compare small to big. So 1, 2, 3 units to 1, 2, 3, 4, 5, 6. Again, I want to stay away from the slanted sides unless I would like to use Pythagorean theorem, which I'm going to pass on. So that would mean then I would compare UT and RQ. Looks like 1, 2, 3, 4, 5. Small on the small side. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 over here. I can compare cross products, 30 and 30. That right there tells me that they are similar. Or if I reduce them both, I would get 1/2. Okay, so those are similar. A is similar. Now let's do B. Compare small to big. 1, 2, 3, 4. So 4 is to 1, 2, 3, 4, 5. 4 is to 5 as small to big. That would be 4 is to 1, 2, 3, 4, 5. Okay, so 4 is to 5 as 4 is to 5. But now you also have to compare something else because those have another flat side of a figure. You have to make sure that all of them go. So right there, that looks like it's similar. Let's compare the other two. Small is to big. So 1, 2 is to 1, 2, 3. See, that one throws it off. So not all sides are the same. So 4 is to 5, 4 is to 5. Those work out okay. The other ones, however, do not. So that one is not similar. That one's not similar. Okay. Using a scale factor. So we talked about scale factors before. You know, just in general mathematics, if you multiply something by, let's say, a decimal, like 0.2, 0.5, 0.75, if you multiply by something less than 1, your number gets smaller. If you do it by a number bigger than 1, let's say 1.5, so you're going to have all of it plus half of it again. So 1.5 would be all plus a half. So that would get bigger. If the number's bigger than 1, the resulting image is larger. If it's less than 1, then it's smaller. And obviously if you multiply something by 1, it would stay the same. So that's the kind of thing they're talking about there. All right, let's look at this problem. Example 3. Okay, it says Ken enlarges the photo shown by a scale factor of 2 for his web page. He then enlarges the web page photo by a scale factor of 1.5. So he enlarges it by 2 the first time, and then he enlarges it by 1.5 the second time. If the original photo is 2 by 3, what are the dimensions of the print? Are the enlarged photos similar to the original? So a couple different questions there. So if we're talking about this, if the original was 2 by 3, and if you enlarge that by a scale factor of 2, you multiply them both by 2, you now have a 4 by 6 print. sorry, 4 by 6 for the web page. So now the web page, which is a 4 by 6, has to be enlarged again by a scale factor of 1.5 for the print. So I'm going to take a 4 by 6, multiply it by 1.5. 4 times 1.5 is 6. 6 times 1.5 is 9. So the actual print, the printed photo, would be 6 by 9. So are all three photos similar? Yes, because you don't even have to do the proportions. Because you did the same thing every time, in fact, they are. They are. You can check it if you wish. If you want to check it using the ratios, the first one was a 2 by 3. The web page photo ended up as a 4 by 6. And the printed photo ended up a 6 by 9. If you reduce these, 4 6 reduces to 2/3. 6 by 9 reduces to 2/3. Or if you want to check cross products, that would be 12, that would be 12. Or if I even wanted to do like 3 times 6 and get 18, I could do 2 times 9 and get 18. You could check any of those cross products. They are, in fact, going to be the same. Okay. So there is one more for you to try, and then this lesson is done. So I want you to pause and try got it for C, and then come back with me and we'll do it together. Okay, an art show offers different size prints of the same painting. The original print measures 24 by 30 centimeters. A printer enlarges the original by a scale factor of 1.5 and then enlarges the second image by a scale factor of 3. What are the dimensions of the largest print, which is the last one, and are both of the enlarged prints similar to the original? So if we talk about multiplying this, we're enlarging this by a scale factor of 1.5. So we have 24, let me get my pen back here, 24 times 1.5. Let's move this out of the way so we can still see the problem. So 24 times 1.5 gives us 36. That would be, instead of a 24 by 30, instead of a 24 by 30, we will now have a 36 by 30 times 1.5 by 45. And if I enlarge this one again by a scale factor of 3, I'm going to take 36 times 3, which is 108. A 108 by 45 times 3, which is 135. So that is the final, this is the biggest one, a 108 by 135 centimeter. And are they similar? Well, yes, because you did 1.5 to both, and then you did 3 to both of those. So as long as you are doing the same thing to both, you have a similar figure. All right? Okay. That concludes that lesson. There are some practice problems if you wish to try further. You can get started on the assignment, and as always, come see me with any questions. Good luck.